ठीक है. Right. Today we will start the new topic of the design of beam. ठीक है. Right. So I need everyone's attention. So what are beams? What do you understand by the term beam? As you can see in the definition part, beams are the structural members. Those are frequently used to carry loads that are transfers to their longitudinal axis. Isn't it? If you consider this horizontal member, the nature of loading which is coming onto that, how do you feel it to be? It is nothing but in the transverse direction along the longitudinal axis of the member. So whenever a load is actually acting along the member in the transverse direction, the behavior of that member is known as beam behavior. Okay? And very significantly, this beam, it bends. So if you remember, I had already told you the difference between beam and column. The behavior is according to the deflection and the loading. In case of beam, the load is in the transverse direction, and because of that loading, it bends. Whereas in case of column, the load is acting in the perpendicular direction and it buckles. So that is the difference. So your major deflection, it will be in terms of bending, right? So they transfer load primarily by bending and shear. See, whenever we talk in terms of a beam, it is resting on two or more supports. Because you can say it may be a simply supported beam or a continuous beam or fixed beam. So what do you understand by all these things? That there are some supports associated to the beam. So based on this support, you know, as because of the presence of the supports, there are reaction force which are developed. In addition to reaction, if it is fixed, moment is also developed, isn't it? So at the ends, particularly at the ends, where supports are available, you can experience shear force also. Okay. So talking in terms of beam as such, it will not only carry the bending part, it will also carry the shear force. Okay. Beams that span between adjacent columns are called as main or primary beams. They are also known as girders. Girders कब कहते हैं? When the depth of the beam is quite more. For example, let's say the metro rail bridge, उसको हम girder कहते हैं, क्योंकि उसका जो depth है. Let's see, the behavior of that complete horizontal member is to transverse bending moment as well as shear force. So it is adjacent to your beam part, isn't it? Why it is known as girder? Because the depth is quite high. It is of the order of 2 meters or so. So whenever you come across such type of beams, which are actually main beams, what is written? Beams that span between adjacent columns. तो यहाँ पे देखो, ये जो beam है, this you can call it as the main beam. You can also call it as girder, because the depth is quite high. It must be around 1 meter or so. Okay. Beams which are used to transmit the floor load to the main beams between the columns, they are known as joist, or they are also known as secondary beam. So if you want to find out what will be the secondary beam in this complete room, from this definition it is very clear. ये जो है, these beams which are running perpendicular to the main beam, they are secondary beam, or they are also known as joist. Okay? So this is the basic difference, and you can now understand the floor load which is transferred from the beam, secondary beam, to the main beam. Okay? Purpose of this secondary beam is to transfer the load which is coming from the floor onto the main beam. Okay? You can understand it from here. What are the actual design requirements for a beam which is loaded predominantly by flexure? Two essential requirements must be made to develop its full moment capacity. In our limit state design method, it is very, very important that whatever material or whatever member you consider, that should yield completely. In the sense, the plastic range or the plastic zone should be reached. Okay? The purpose is complete usage of the material should be done. Otherwise, elastic theory या फिर हम working stress design में क्या करते हैं, उसको restrict करते हैं up to only yield. Not only yield, even before yielding. जिसको हम factor of safety लगा के उसको और छोटा कर देते हैं. Over here, complete MP value, plastic moment capacity, that has to be reached. So what are the requirements? First is, see, we are talking in terms of steel structures. Okay? Behavior of the steel structure beam will be same as your RCC beam. Analysis wise it will be same. But now since the beams or the members which we are talking about, these are steel structure or structural steel. And as you all know that the structural steel are open members. For example, I section, channel section, box section, isn't it? They are not solid sections. And because of which, while discussing the design requirements, we need to take into account that these members are open sections. And being open sections, they will have different components like the flanges, webs, right? So we will be talking everything, or we will be discussing the design requirements with respect to these components only, that is web, flanges. Okay? So what are the requirements? First, the elements of the beam, that is flange and the web, should not buckle locally. Local buckling should not be there. And do you remember what is local buckling? Local buckling is the distortion in plane. And it is not necessary कि कोई external load आने पर ही वो local buckling होगा, ऐसा कुछ नहीं. There may be a possibility that because of its self load or self weight, the elements of the member, they may not distort. अगर उसपे ऐड कर दिया कुछ dead load या live load, तो वो तो होगा ही. In order to restrict all this, what do we do? In order to restrict the local buckling, we maintain the depth by thickness ratio, or the aspect ratio, what we call it as. Okay, that has to be maintained. So first requirement is the elements of the beam should not buckle locally. Second is beam as a whole should not buckle laterally. Lateral deflection नहीं होना चाहिए. ठीक है? We will discuss about this, how that lateral deflection occurs. I will show you one video. In that you will understand how is the behavior of a beam which deflects in the lateral direction. It not only deflects in the lateral direction, but it also gets twisted. This is a very common phenomenon for beam structures. ठीक है, they will not only deflect in the lateral direction but they will also get twisted. That is known as lateral torsional buckling. Buckling in the sense the load which is applied, it is acting in the perpendicular direction of the deflection. That's why. So I will show you the video, you will get the complete idea. See, for first, how we can make it sure that the members doesn't get locally buckled. It is very simple. To ensure the first condition, the cross section of the flange and the web chosen must be plastic or compact. देखो आप लोगों ने डिजाइन किया है, मेंबर्स डिजाइन किया है, तो डिजाइन करते वक्त आप लोगों ने कॉम्पैक्ट सेक्शन या फिर प्लास्टिक सेक्शन इसको ही स्ट्रेस दिया है. Reason being, they are quite robust and they will ensure that local buckling cannot take place. अगर इनिशियल स्टेजेस पे फेलियर दिखाई दिए तो बाद के डिजाइन का कोई मतलब ही नहीं है. So at the initial stage itself, you are supposed to make sure that your member doesn't fail in local buckling. And in order to do that, you are supposed to decide upon these dimensions in such a way that the member will behave in a plastic or compact section manner. Okay. Second, to avoid the lateral buckling, for the second case, restraints are provided to the beams in the plane of the compression flange, and hence such beams are called as laterally restrained beams. ये एग्जांपल मैं आप लोगों को देता हूं. जस्ट ये आरसीसी का एग्जांपल है, बट द बिहेवियर इज सिमिलर. ये देखो, ये कंप्लीट बीम सेक्शन है. लैटरल डायरेक्शन में देयर आर सपोर्ट्स, इफ यू कैन नोटिस. एक सपोर्ट है रूफ का स्लैब, दूसरा सपोर्ट है ये सेकेंडरी बीम्स. तो इन द लैटरल डायरेक्शन, बेस्ड ऑन द वर्टिकल लोड, you will find that there are supports at intermediate levels, and because of which this complete beam under live load or dead load, it won't buckle in the lateral, or it won't get deflected in the lateral direction. Lateral direction का मतलब समझिए क्या? In this direction it won't get deflected क्योंकि यहाँ पे restriction है, isn't it? Such type of restrictions, if provided to the beams, will help against the lateral deflection of any beam or girder as such. Okay? So this is how these are the basic things as far as the beam design is concerned, and we should keep these two things in mind. Very simple things. पहला तो है जो डिजाइन हम करेंगे, that design should be either compact or plastic. Second is, in order to avoid the lateral deflection, we are supposed to provide some kind of restraints. How to provide, when to provide, that we will be discussing. Okay. So these are known as laterally restrained. I have written one note. In many steel structures, especially in buildings, beam carry deck floor, rather floor decks on the top of them, and these floor decks provide restraints to the compression flange. I have seen your assignments, and most of you, I'm in the first assignment, okay, and most of you have taken selfie in the industrial buildings. You must have observed in the industrial buildings at various floor levels, concrete is done. These are again floors which are made up of RCC. But before that RCC, you will notice that there are some kind of sheets, corrugated sheets, which are placed. Above these corrugated sheets, such type of reinforcements are placed, and then concreting is done. That is known as metal decking. That is known as metal decking. It is a permanent kind of structure wherein you will find these corrugated metal sheets, they are embedded in the concrete itself. Okay? And in that process, what happens? Because we are talking in terms of floor. These floors, they rest on the beams. You agree? Okay. So while concreting, what is done? The upper flange of the any section that gets embedded in the concrete, and you will see such type of cross section. Got it? ये जो है क्या हो रहा है इसमें? ये जो टॉप फ्लांज जो है ये आई सेक्शन का, okay, that has got embedded into the concrete. Then such kind of cases, they are known as laterally restrained kind of cases. कहने का मतलब है कि ये lateral direction में deflect नहीं होगी अगर upper flange of the beam is embedded in the concrete. ठीक है, this is one such example of laterally restrained type of beam. ऐसा जरूरी नहीं है कि हर वक्त हम I section ही यूज करें. It depends on the type of the structure, the requirement. These sections may be I section, it may be channel section, it may be even T section. हो सकता है. It depends on the requirement, right? And the design. So whatever may be the case, if the upper flange of the section is embedded in the concrete, then it is known as laterally restrained. That means it is not allowed to move in the lateral direction. Concrete is such that it will ensure that it won't move in the lateral direction, and you will see that it is restrained in that direction, particular direction. This is one such case. Second case, how to increase the stability of any section in the lateral direction. This is first case. Second case, as you can see, the web portion is restrained at intermediate level. Just take example of ये जो बीम है, अभी इसको भूल जाओ, ये आरसीसी, आप ये पकड़ के चलो, ये पूरा आई बीम है, ठीक है, और इसके वेब पोर्शन पे अगर आप देखोगे ये जो सेकेंडरी बीम्स क्रॉस हो रही है, don't you feel that this figure is same as this? Isn't it? So in the lateral direction, again, you can find the restraint can be provided in such a way. So either in the flange or in the web. Got it? Third case, ये दिख रहा है आप लोगों को? ये एक प्लेटफॉर्म है. मैंने बहुत सारे असाइनमेंट में ये भी देखा कि शेड या फिर रेलवे प्लेटफॉर्म पे भी आप लोगों ने सेल्फी खींची है. That is a very good thing, and I hope you must have observed such kind of arrangement. तो यहाँ पे भी आप देखो, ये जो फ्रेम स्ट्रक्चर यहाँ पे दिया हुआ है, ये है आपका कंप्लीट मेन बीम, यू कैन से, और गर्डर, and at intermediate levels in the lateral direction the stability is retained, and such kind of beams are known as laterally restrained. Okay, so very frequently you will come across laterally restrained type of beam structures. There may be, now you may argue that why only laterally restrained, why not laterally unrestrained? And they are present. Laterally unrestrained beams are also present. उसका एक typical example है gantry girder. Okay, it is gantry girder. I will now introduce gantry girder. ठीक है. Now see, have you seen such kind of cranes in industrial sheds? अपने वर्कशॉप की बिल्डिंग में भी है, दूसरा जो इंडस्ट्रियल इंजीनियरिंग का जो एक वर्कशॉप बनाया है उसमें भी ये गर्डर प्रेजेंट है. The main purpose of this girder is to carry heavy equipments from one place to another, and you will notice that the movement of this complete unit is in this direction. So can you see this? Are you able to see this thing? This is nothing but a beam, and the movement of this complete crane. यहाँ पे भी एक beam है, ये देखो. ठीक है? These are the two beams over which this crane is placed, and the movement of this crane is along the longitudinal direction of these two beams. Now see, this is the crane and this is the beam on which the complete crane moves, right? Now the purpose of showing all these things to you is, ये जो beam है, these beams are actually not supported in the lateral direction. They are kept free. Reason is, there should not be any kind of hindrance as far as the movement of this crane is concerned. If we provide any kind of restriction in the lateral direction, then there will be problem for the movement of the crane. So such type of typical cases you can find as far as laterally unrestrained beams are concerned. तो इसका डिजाइन और अलग है, क्योंकि अगर हम कहते हैं कि वो lateral direction में supported नहीं है, problem है. Additional care has to be taken. So don't worry, IS code has provided several clauses based on which these laterally restrained and unrestrained cases can be easily dealt with. Okay, so you can go through this video, any of the videos. ये देखो, ये जो दिख रहा है आप लोगों को, beam. Typical cross section is I section, but the design procedure is a bit different. There are few conditions which are to be taken care of. So fine. Now see, lateral torsional buckling. ये शायद मैंने आप लोगों को दिखाया था, but ठीक है, कोई problem नहीं. I will revisit this video. This is very important. Otherwise वो समझते नहीं उसका behavior कैसा है. So let's see. This is an I section which is considered. These are the dimensions, and loads are applied. Now you will appreciate that only vertical loads are provided. No lateral force is acting, even though the beam gets deflected in the lateral direction. And not only in the lateral direction, but you will see that it gets twisted. देखो, vertical direction में loading लग रहा है, and slowly this beam is getting deflected. Now just observe carefully. ये वाला section देखो, load बढ़ रहा है, and what do you observe? See, ये देखो, ये direction में वो deflect हुआ है. Vertical direction में loading है, लेकिन deflect इस direction और perpendicular direction पर, that is buckling. And in addition to buckling, ये जो cross section है, ये देखो, ये twist हो चुका है. Okay, so this is the complete behavior of lateral torsional buckling, and this you will see mostly in case of unrestrained type of beams. जहां पे lateral stability है नहीं, उस केस में lateral torsional buckling behavior आना ही है. जिस बीम को laterally हमने support कर रखा है, उसके लिए कोई problem नहीं. ठीक है? So IS code has provided few formulations based on which you can keep that complete unrestrained beam in check, and it won't twist, and it won't even buckle. That is, lateral torsional buckling can be kept in check. So fine. So I hope you have understood these things. Okay, restraint, unrestrained. So most of the time you will find that in multi-storied building structures, the beams, whatever beams are there, and if that multi-storied building is made up of structural steel, in that case you will find that the beams are laterally restrained. There is no such problem. Okay, so we will go through the design process. There are few steps; those are to be followed for each two cases, that is restrained and unrestrained. And meanwhile, few explanation will be required. I will let you know. Okay. So major is bending moment and shear force. These are the two cases which you are supposed to handle for both the uh, unrestrained and restrained case. Okay. So we will take up one example. Acha, before this, how many types of bending are you aware of? If I take example of any beam, may it be simply supported or continuous, how many different types of bending you know? Have you ever heard about simple bending or plain bending? Simple bending. क्या हो सकता है simple bending? Bending only in one direction, correct? Okay, and that bending which takes place in either in principal, major principal or minor, that is simple bending. लेकिन ऐसा होता है नहीं. Why? Because of the presence of this local buckling phenomena. Early distortion may take place. ठीक है? Secondly, all the time you will not find that the cross sections of the members are symmetrical. I section मान सकते, that is symmetrical section. But what about channel section? देखो channel section हमने as a horizontal member कहाँ पे देखा है? Plain horizontal member and the cross section is channel section. कहाँ पे देखा है हमने? अभी कंप्लीट किया हमने ट्रस में पर्लिन्स, isn't it? Purlins, they are horizontal members, so you can also call purlins to be part of beams. Function is same, they are resting on two supports, two or more supports, whatever it may be. And what load do they carry? In the transverse direction. So you can consider that to be beam, but the cross section is C type, unsymmetrical. तो ऐसे unsymmetrical sections के लिए अगर transverse load लग रहा है, तो don't you feel that it will not bend in the direction which it has to? For that, in order to keep that complete bending in one direction, which we call it as, theoretically we call it as simple bending, we have to, for such unsymmetrical cases I am talking about, the load should act at its shear center. Shear center आप लोगों ने strength of material में concept पढ़ा है, isn't it? So in order to have simple bending in one particular plane, the load should act at this shear center for such kind of unsymmetrical sections. Symmetrical section का तो कोई issue ही नहीं, ठीक है? So this is one simple bending type. दूसरा है अपना unsymmetrical bending. Unsymmetrical bending are nothing but the bending for the unsymmetrical sections. And third is biaxial bending. Biaxial bending में क्या होता है? The bending will take place in about both the planes, right? So these are the different types of bendings which one has to keep in mind whenever we are going for the design of any kind of beam. So सिंपल बेंडिंग का अगर हम केस लेते हैं तो हमको दो चीजें ध्यान में रखना है, एक तो लोकल बकलिंग फिनोमेना और दूसरा है शियर सेंटर अगर अनसिमेट्रिकल सेक्शन है। बायएक्सियल बेंडिंग में तो कोई प्रॉब्लम नहीं है, दोनों साइड में बेंडिंग हो रहे हैं तो दोनों साइड का हमको चेक करके खत्म करना, नो प्रॉब्लम, ठीक है। नाउ with this all theoretical concept and whatever explanation I have told you, few things which we need to remember, that whatever design we are doing for beam, especially for the steel structure, it should be in compact or plastic zone firstly, that is local buckling should be taken care of, and second is what we can say is complete beam whatever we are designing, that should be restricted in the lateral direction. If not, then we are supposed to make certain provisions. Okay, that we call it as the laterally restrained and unrestrained case. So we will be discussing both these cases, we will be designing both these cases, and let us try to understand how the process is. Okay, so let us begin with, अब ये जो प्रॉब्लम स्टेटमेंट मैंने लिखा है स्ट्रेट फॉरवर्ड लिखा है, मुझे मालूम नहीं है कौन से टाइप की बीम है, वेदर इट इज सिंपली सपोर्टेड, कंटिन्यूअस या फिक्स, कुछ भी नहीं मालूम है। इसमें जस्ट लिखा हुआ है, क्या लिखा है, डिजाइन अ लैटरली सपोर्टेड बीम ऑफ इफेक्टिव स्पैन 6 मीटर फॉर मैक्सिमम बेंडिंग मोमेंट दिस एंड मैक्सिमम शियर फोर्स दिस, दैट्स। अब इसको कैसे विजुअलाइज करोगे आप लोग, ये ऐसा प्रॉब्लम स्टेटमेंट है, इसको कैसे विजुअलाइज करोगे, रिवर्स इंजीनियरिंग कैसा करोगे, क्या हो सकता है ये कंडीशन। क्योंकि एग्जाम में तो आप लोगों को ऐसे ही न्यूमेरिकल आते हैं, कोई ऐसा थ्योरेटिकल ऐसा कोई ये ऐसा बिल्डिंग है, फिर उसमें ऐसी बीम है, उसका फ्लोर से अटैच्ड है, इतना लोड आ रहा है, वो ट्रांसफर हो रहा है, नहीं हो रहा है, कुछ भी नहीं है, ऐसा कुछ नहीं है, स्ट्रेट फॉरवर्ड। बट एज एन इंजीनियर यू शुड नो, डोंट यू फील सो। ये प्रॉब्लम स्टेटमेंट ऐसा पॉइंट ब्लैंक दे दिया, अभी इसको थोड़ा सा सोचना है आप लोगों को कि ये कहां से कैसे आया होगा। सो कैन एनीवन ट्राई एंड कैन एनीवन टेल मी कि इसका जो बैकग्राउंड है वो कैसा हो सकता है। We can discuss. तो देखो लैटरली सपोर्टेड लिखा है, तो मैंने जैसे आप लोगों को एक्सप्लेन किया कि मोस्ट ऑफ द मल्टी स्टोरीड बिल्डिंग्स व्हिच आर मेड अप ऑफ स्ट्रक्चरल स्टील, उसमें क्या है, जो मेटल डेकिंग या फ्लोर डेकिंग जिसको हम कहते हैं वो प्रोसेस फॉलो होती है। इसका मतलब this beam may be embedded in the, rather the top flange of this beam may be embedded in the concrete, ये एक हम assume कर सकते हैं, and that assumption is very correct, assume भी करना है ना, कोई दिया तो कुछ नहीं है, ठीक। दूसरा support, that support may be considered as fixed or hinged, कुछ भी कंसिडर कर सकते हैं। यहाँ पे सिंगल बीम दिया है, इसका मतलब ये कंटिन्यूअस बीम का पार्ट हो सकता है या नहीं भी हो सकता है, सो वी कैन कंसिडर एनी ऑफ इट, ठीक है। फॉर टाइम बीइंग लेट मी कंसिडर दैट इट इज सिंपली सपोर्टेड, ठीक है। सो वी कैन अज्यूम दैट दिस पर्टिकुलर बीम व्हाटएवर इज गिवन इन दिस न्यूमेरिकल, टॉप फ्लैंज ऑफ द बीम इज एम्बेडेड। अभी मुझे क्रॉस सेक्शन भी नहीं मालूम है कि वो चैनल सेक्शन रहेगा या टी सेक्शन रहेगा या आई सेक्शन रहेगा, मैं समझ रहा हूं। लैटरली स्टेबल, लैटरली सपोर्टेड, लैटरली रिस्ट्रेंड, ठीक है। तो ये दो कंडीशन, इसका मतलब है वो मल्टी स्टोरेड बिल्डिंग का एक ये बीम पार्ट है, it may be a part of continuous beam or simply supported beam or single beam rather. And I am assuming it to be a simply supported case. Done. अभी इसके ऊपर लोडिंग कैसा है? क्योंकि इन्होंने डायरेक्ट मैक्सिमम बेंडिंग मोमेंट और मैक्सिमम शियर फोर्स वैल्यू दिया है. How that loading must have been calculated? कैसा? कैसा? तो जस्ट इमेजिन यही केस पकड़ लो ना आप लोग. ठीक है, ये रूफ है, कंप्लीट रूफ में वो एक बीम एक पार्ट है. रूफ का जो लोड है वो ट्रांसफर हो चुका है उसके ऊपर. ठीक है, अब वो रूफ मुझे नहीं मालूम वेदर इट इज वन वे स्लैब और टू वे स्लैब. आई डोंट नो अबाउट दैट. Whatever may be the case, the load is coming from that slab onto the beam that is getting transferred. यहाँ पे देखो दो ही टर्म्स दिए हैं, मैक्सिमम बेंडिंग मोमेंट और मैक्सिमम शियर फोर्स. एंड मोमेंट के बारे में कुछ नहीं दिया. दैट मींस माय assumption of simply supported beam is okay. Am I right? मैक्सिमम बेंडिंग मोमेंट आपको सेंटर में मिलेगा और मैक्सिमम शियर फोर्स आपको एंड में मिलेगा. दैट्स इट. So this is how you can interpret, you can imagine, you can visualize depending upon whatever problem statement is given. बाकी प्रोसेस तो दी हुई है, आप लोगों को मालूम ही है वो कैसे करना है क्या करना है. इट इज वेरी सिंपल. ठीक है, बट एज एन इंजीनियर यू आर सपोज टू थिंक. और ऐसा रिवर्स थिंकिंग से ना बहुत सारी प्रॉब्लम्स सामने भी आती है. एंड देयर इज अ हेल्दी डिबेट. आप लोग अगर थोड़ा सा इसके ऊपर थोड़ा सा अगर डिबेट करेंगे तो इट विल बी वेरी वेरी फ्रूटफुल. अमंग्स योरसेल्फ यू कैन डिस्कस. ये ऐसा भी हो सकता है, ऐसा भी हो सकता है. और वो डिस्कशन में हो सकता है कि व्हाटएवर आई एम सेइंग इट मे बी रॉन्ग, कुछ और ही हो सकता है. सो दैट इज हाउ यू आर सपोज टू डिस्कस थिंग्स. तो एनीवे, फॉर टाइम बीइंग, based on the data and based on the information whatever is given, my assumption I am considering it to be true. Based on that, now let us design. तो देखो सबसे पहले ये स्टेप्स है, ये बहुत मैनुअल मैकेनिकल स्टेप्स हम कहते हैं उसको, वो आपको याद रखना है. पहला है, since we are supposed to take into account the local buckling, the fullest capacity of the material should be taken into, or it should be taken care of. So because of that, plastic moment capacity of that section is to be evaluated. So देखो plastic section modulus required, which is ZPZ, that can be evaluated from this formulation. And this formulation is very simple. Moment is equal to ZP into Fy divided by gamma m naught. Partial safety factor of material is always included because we are discussing everything with respect to limit set design. So ZPZ required will be m into gamma m naught divided by Fy. यहाँ पे मैक्सिमम बेंडिंग मोमेंट ऐसा लिखा हुआ है. That means it is factored bending moment. You need not to factor it. It is already given. Maximum का मतलब है it is factor. Then you do the calculation, and before see whatever calculation you do, whatever formula you write, you are supposed to mention the IS code clause. For example, gamma m naught वो कहाँ से आया, उसकी वैल्यू क्या है, वो टेबल का रेफरेंस आप लोगों को देना है. Now based on this ZPZ value, ठीक है, we will be selecting one section which will be sufficient for our design purpose, and that section you can try from your IS 800 2007. So can you please open IS 800 2007? Annexure H, page number 138. annexure H. So in that you will see plastic properties of beams. टिपिकल आई सेक्शन के का जो इंफॉर्मेशन है वो दिया हुआ है पेज नंबर 138. So in that, can you locate ISLB 350? ठीक है, ISLB 350 वहां से आप अगर देखोगे, I have written down the properties like section depth, then the flange width, thickness of the flange, thickness of the web, and root radius. Sorry, R1. Yes, R1 is the root radius. Root radius. Yes, root radius. Now see, दिख गया आप लोगों को ISLB 350, sorry ISLB 350. अच्छा, ISLB 350 का सेक्शन मॉड्यूलर, प्लास्टिक सेक्शन मॉड्यूलर कितना दिया हुआ है? 851. 851 है, 851.11. ठीक है. So remember, you are supposed to consider the ZPZ which has to be provided. It should be more than ZPZ which is required. तो अब अगर आप देखोगे कि बाकी के भी सेक्शंस है जैसे ISWB, ISLB, ठीक है, that is more than 660 10 raised to power 3, but I am taking it on the further higher side. 10 to 20% आप उसको इंक्रीज करके रख सकते हो, कोई प्रॉब्लम, ठीक है. So we will try this, and based on this, let us see whether the design is safe or not. ठीक है. So there are few terms which you need to calculate, such as this small d. This small d is nothing but this complete distance h minus 2 times thickness of the flange plus this R1. ये जो आप ये R1 जो है आप लोगों को इसमें दिख रहा है क्या? रूट रेडियस. इसमें नहीं दिया है. फॉर दैट यू प्लीज रेफर स्टील टेबल. स्टील टेबल, प्लीज रेफर स्टील टेबल टू कैलकुलेट R1 वैल्यू. आई होप R1 आपको विजिबल है. ये जो है So is the value of R1 correct for ISLB 350? Just verify. दिखा? नहीं दिखा? नहीं. ठीक है, R1 16 mm. I hope others have also got that value for R1. What is the column number? Column number क्या है उसका? पेज नंबर 9. और कॉलम नंबर कौन सा है जहाँ पे रूट रेडियस की वैल्यू दिखी है? Column number 9. So please verify others. I hope all of you have got that value. Page number 9, column number 9. For steel table, steel table का दिख गया क्या? ठीक है? Shall we go ahead? Shall we move? So see, this is how that D value has to be evaluated. This is the depth of the web. Okay. So you substitute the proper values, we will get this value of depth of the web to be 295.2. Okay. And again, now you see, for ISLB 350, IZ value, I have written this, you can verify, ZPZ value and ZEZ value. These are to be identified because from this information we will check in which category that complete section falls, whether it falls in the compact, semi-compact, plastic, slender, whatever, that has to be verified. So section classification, outside of the flange element, which is given as B is equal to BF by 2. This you can see on page number 19 of your IS 800-2007. So please open page number 19, but 9. Can you see the figure? Figure 2, dimensions of sections. उसमें देखो, rolled section कहाँ पे है? Rolled beams and columns. ठीक है? पहला ही है figure 1, if I am not wrong. First figure of figure 2. उसमें देखो small d ये represent किया है, small b represent किया है, small b. ठीक है? Meaning of that small b is flange width divided by 2. Okay. Then we will check the aspect ratios like B by TF and D by TW in order to check whether it falls in plastic or compact or classification of cross section. That's what we are supposed to do. Okay. So the ratio B by TF, it comes out to be 7.23. D by TW, it comes out to be 39.9. These values are to be checked with the with table number 2, page number 18 of your IS 800-2007. So table 2, please open table 2. Okay. Now see, for table 2, there are several compression elements which are given. Out of that, you are supposed to select the appropriate section. तो इसमें से कौन सा section आप choose करोगे? देखो, outstanding element of compression flange, which is rolled section, welded section, internal element of compression flange, compression due to bending, axial compression, etc. ठीक है? So you will see that almost for all cases, जैसा उन्होंने इसके बारे में लिखा है, web of an I, H और box section, उसके बारे में भी मेंशन किया है। एंगल कॉम्प्रेशन ड्यू टू बेंडिंग, बोथ क्राइटेरिया शुड बी सेट। सिंगल एंगल, डबल एंगल, आउटस्टैंडिंग लेग ऑफ एंगल, इन आउटस्टैंडिंग लेग ऑफ एन एंगल, अगेन स्टेप ऑफ द टी सेक्शन, ये सब केसेस के लिए उन्होंने B/TF एंड D/TW ये रेशियो आइडेंटिफाई किए हैं। ठीक है, हम लोगों को क्या करना है, फर्स्ट केस दैट इज फॉर रोल्ड सेक्शन, वो हमको चेक करना है, दैट्स इट। ओके, so what are the limits which are given? So for example, if you see the second column, column 2, B/TF रेशियो दिया है उन्होंने, उसके बाद कॉलम 3 में अगर ये B/TF रेशियो लेस देन और इक्वल टू 9.4 टाइम्स एप्सिलॉन वैल्यू आता है, तो वो क्लासिफिकेशन कॉम्पैक्ट में जाएगा। ठीक है, अगर वो B/TF रेशियो अप टू 10.5 एप्सिलॉन आता है, इट विल गो इनटू कॉम्पैक्ट, एंड 15.7 एप्सिलॉन का अगर वो रेंज है अप टू दैट, then it will be semi-compact section. So based on this, we are supposed to recognize whether the B/TF ratio is compact, semi-compact or plastic. ठीक है, so let us see कितना है B/TF ratio. It is 7.23. I have written it as less than 9.4 epsilon. Epsilon over here it stands the value of under root of 250 by Fy. Fy value प्रॉब्लम में दिया हुआ है कि it is 250, so therefore epsilon value will be 1. ठीक है, and therefore this whole value will be only 9.4. So it is very clear, 7.23 is less than 9.4. This portion of what we call it as the flange, it will lie in the compact section. Correct? वैसे ही वेब पोर्शन का आपको चेक करना है, तो वेब पोर्शन का उन्होंने दिया है, देखो D/TW रेशियो, it should be less than 84 times epsilon. ठीक है, so you can see the D/TW ratio in the first column. देखो, वेब ऑफ एन आई एच और बॉक्स सेक्शन, वेब पोर्शन के लिए उन्होंने दिया है। पहला जो डिस्क्रिप्शन है दैट इज फॉर द फ्लांज, सेकंड इज फॉर वेब। तो हमारा जो क्रॉस सेक्शन हम कंसीडर कर रहे हैं, इट इज एन आई सेक्शन, isn't it? So for the I section, D/TW ratio, neutral axis at the mid depth, we are assuming the I section to be symmetrical, IS/LB 350, उसका न्यूट्रल एक्सिस जो है वो मिड डेप्थ पे ही है, तो इसलिए हम वो जो वैल्यू है 84 एप्सिलॉन, 105 एप्सिलॉन, 126 एप्सिलॉन, इसको रेफर करेंगे। आर यू गेटिंग मी? ठीक है, अगर वो मिड डेप्थ न्यूट्रल एक्सिस अगर मिड डेप्थ में नहीं है, देन यू आर सपोज टू चेक फॉर द अदर केसेस, बट राइट नाउ since we are assuming I section which is symmetrical, neutral axis is it is equal area axis, so therefore 84 times epsilon 105, तो कितना आ रहा है D/T? हाँ, 39.9, which is less than 84 epsilon or 84 value, so therefore again it falls under the category of plastic section. That means my complete section, whatever I have assumed, the web portion as well as the flange portion, it lies in the compact section itself. So it is okay. Like the local buckling can be eliminated because both these elements, that is flange and the web, they lie in the compact section. So this is fine, right? Once we have decided that, then we can go further for the design process. That process I will be discussing in the next class. What is the scene for tomorrow? Classes हो रहे हैं? Just inform me, huh?